Hi, we will be understanding 2D dynamic programming today with the help of a problem, finding the shortest path. In the problem, we have been given a grid, and our task is to reach from the top left corner to the bottom right corner. In the grid, 0 represents a path, and 1 represents an obstacle. We can move in two directions, down and right. We need to return the count of all possible unique paths. Let's begin. We start from the bottom right point and make our way up. We went up and left. Every time we reach the finishing point, we increment the counter. This is the visualization of the problem. As we see, there are 3 unique paths in this grid when we exhaust all the possible ways the function concludes. Now, let's look at the C++ implementation of this problem. The function func, I, j, obstacle grid, v, is a recursive function that calculates the number of unique paths to reach the given cell, I, j. First, we check the base cases. If we have reached 0, 0, meaning the starting position, and there is no obstacle, we return 1 since it is a valid path. If we are out of bounds or we land on an obstacle, we return 0 since this is an invalid path. To optimize our solution, we use memoization. If the value of v, I, j, has already been computed, we return it instead of recalculating. This prevents unnecessary recursive calls and improves efficiency. The recursive formula we use is that the number of ways to reach, I, j, is the sum of the paths coming from the top, I1, j, and from the left, I, j1. We store this result in v, I, j, to avoid redundant calculations. The main function, unique paths with obstacles, first retrieves the dimensions of the grid. It initializes a 2D vector v with -1 to store computed values. We then call the recursive function func, n1, m1, obstacle grid, v, from the bottom right corner to compute the total number of unique paths while avoiding obstacles. Finally, we return the computed result. This approach effectively uses dynamic programming with memoization to optimize the recursive solution. That's it for this tutorial on 2D dynamic programming and unique paths with obstacles. If you found this helpful, make sure to like the video and subscribe to the channel for more such problem-solving content. See you in the next one.